When you're solving equations that involve logs, it's sometimes helpful to remember that if you have, like, I don't know, like b to the x is equal to a, that there's an equivalency that says log base b of a is equal to x. And notice that the base of the log and the base of the exponents are the same, but just your input and output have switched because they're inverses of each other. We just quizzed on that. So if you're presented this, sometimes it's easier to think this and rewrite your equation. So when I go back and take a look here at this example, I might want to rewrite this. 2 to the x is equal to 1 over 32, if I don't see what the answer is like right away. So I could rewrite 2 to the x is equal to 1 over 32, and then think about what power of 2 is 32. So 2 to the x is equal to 2 to the negative 5th. And again, when your bases are the same, this is a 2, this is a 2, therefore the x and the negative 5 must be equal to each other. So then I get x is equal to negative 5. Now, if you know that logs just count powers, so log base 2 is looking for powers of 2, and you realize that 1 over 32 could have been rewritten. So I could say log base 2 of 2 to the negative 5th is equal to x. If what's inside is a power of what the base is, the whole point of a log is it counts how many of those exponents there are. There are negative 5 of them. So you could also get to negative 5 by just using log properties, I guess, or knowing what logs count. Okay. 10, again, a rewrite is fine. 6 to the second power is equal to 2x minus 7. And then that's 36 is equal to 2x minus 7. We add 7, so we get 43 is equal to 2x, or x is equal to 43 over 2. Now, in this case, I have my natural log, which remember is log base e. So if that helps you to rewrite that, that's fine. And then you say e to the 4th power is equal to x squared. Now I'm going to have to introduce a square root here, and I'm picking up a plus or minus, which I should be super cautious about because logs can only be evaluated with positive domain. But the fact that I'm squaring it, though, before I take the log tells me I'm still going to be okay in this particular example. I'm introducing the square root, so it's going to be plus or minus the square root of e to the 4th power is equal to x. And if you remember that the square root's the 1/2 power, this is technically then plus or minus e to the 4th power to the 1/2 power, and 1/2 times 4 is 2. So plus or minus e squared. So they both would work, even though negative e squared is negative a value, you're squaring it before you evaluate the log. Okay, and 12 and 13, each of them have their logs as bases, or the exponent, I should say, is the base of the log. Still, you could solve it using the rule x plus 4 squared is equal to 100. Now, before we square this out and think about solving it, realize you have two perfect squares. So let's just square root both sides. We have to introduce a square root because we're plus or minus, so we'll do that. But that's x plus 4, if I square root this, is equal to plus or minus 10. Much quicker. And then subtract 4. So x is equal to negative 4 plus or minus 10. So x could equal 6, or x could equal negative 14. And again, we have to be cautious. We can't take logs of negative numbers, and at the same time, our base can't be a negative value because that would have implied that our exponent was outputting negative values. So there's no such thing as negative 10 as our base, and so like that is an extraneous solution, so it's 6 only. Can't have a negative value as the base, and can't have a negative inside there, even though the quadratic algebraically would have made it work. Okay? And then our last example for this so far, I'll do x to the second power is equal to 2x plus 3. And already it's quadratic, so I'm anticipating two solutions. But there's an x here and an x here, and I've got to be cautious that if I get negative values in those positions, I'd have to throw them out as extraneous solutions. So then I factor. Should have given you guys completing the squared problems. And so that is x minus 3, x plus 1. So x is equal to 3 or negative 1. And again, a negative 1 as a base doesn't make sense, even though that works there. But 3, positive log base 3 of 9, yes, is definitely 2. And again, you could check your work. Like what I just had finished, log base 3 of 9 is equal to 2. Remember, logs count powers. How many powers of 3 will you need to get a 9? You need 2. You need 2 of them. Okay? Excellent. So those are those equations. And then in the next video, we'll look at, number 14.